next speaker is from the Catapult. It's Martin Pett, who looks after the virtual reality lab. This certainly does look quite futuristic, Juliana. Juliana wants some more whiz-bang future stuff. And so Martin's going to tell us how virtual reality fits into helping to support transport models.
Good afternoon. Hi there. My name's Martin Pett, and I look after the visualization capability here at the Transport Systems Catapult. So today I'm going to talk to you about the potential for virtual reality to support modeling and simulation. So we started looking into visualization technologies about 18 months ago, and we wanted to establish what exactly we needed to do to try and move forward in visualization. We assessed the market and saw there's a lot of visualization technologies that exist and are owned by simulation companies. So the last thing we wanted to do as a Catapult was duplicate what's been done already. We needed to look towards the horizon and see what technologies we could cherry pick from inside transport and in the adjacent industries and apply to transport simulation. We also had a responsibility to create visualizations for the communication of all the other projects that we do within the Catapult, often being very complex and need to be disseminated at multiple levels to different end users. So the investigation really highlighted virtual reality as being one of those on the horizon technologies that could have an impact. And for those of you who've been around long enough, you might have heard it before and see it come and go. So I was initially very skeptical about whether or not it would actually have any real value and have any longevity. But being a human factors person, I understood that a lot of limitations were down to the hardware and software not being able to generate the kind of visual fidelity that you need and to minimize what we're probably all familiar with, motion sickness that has been plagued by previous iterations that have come and gone and failed. So through the investigation, it highlighted that a lot of people were starting to take it very seriously this time. And this graph on here is probably about 12 months old now. It's a Goldman Sachs report, but it shows the potential applications of virtual reality across different industry sectors. So not just in gaming. Obviously, gaming are the ones who are putting the money in to create the hardware and the software to run these these high computationally demanding visual effects. But hopefully, we can all benefit from their investments and find serious applications that add real value. So I think it was about 12, 18 months ago, Facebook invested $2 million, and about 3-4 months ago, the first headset started to become available commercially. So it's looking good as an area to investigate. The other thing that was clear that we'd got to that point in time was there was an appetite and there's also a computational capability at an affordable price that was going to make it more accessible to more people. If this was going to be available to only those people with deep pockets, it's not going to really have that traction. So again, the gaming industry are very influential in making sure the price point came down and would allow us to use it more across industry. And the other thing, as a human factors person, I was quite excited about was how can we bring you as a person into virtual reality to make it more engaging? As a gamer, traditional peripherals are your backside's on a sofa, you've got a controller, you work your thumbs a lot, and that's about it. Some of the peripherals that are being developed and talked about meant that you could have a full body experience. You can move around, you could interact in a more natural way. And I knew that was going to be enabling for the technology for more people who are not from a gaming background. So that was particularly interesting. So we've invested in a few bits of technology about 12 months ago and have been experimenting with that technology. Another thing of quite interest is a recent business case study is showing that virtual reality has a certain amount in the market, but augmented reality is the big player. And they're talking about 120 billion per year in terms of overall market size by 2020. So the distance into the future where this is going to have an impact is getting closer and closer, and the figures seem to be indicating that it's going to get bigger and bigger. I can see there's still some skeptics in the audience. So I wanted to apply some of the best practice from human factors to think about the end user. If you're going to make a product have any real value, what problems it's solving, who is it for, And I wanted to make that central to the development of capability here at the Catapult. So thinking about decision makers, thinking about the process of delivering solutions, who's involved, in what way, what relationship, how do they engage with each other, where are the obvious barriers and challenges that are out there, and how can we get people to come together. And my belief is that picture, well, everybody knows the picture speaks 1,000 words, but I really think that if you can sketch something up and get everybody to engage at a low level, you can then add more and more detail into that visualization. And so I spent a lot of time talking to the modelling guys. My background's in human factors. Worked in kinetic in the military industry and in the automotive industry, so modelling is new to me. So I suppose a bit of a curse and a blessing in the sense I could look at it with fresh eyes, but a huge amount to try and learn, and I still feel I'm learning today about what simulation is all about. But what I do understand is how the end user is going to perceive and use that simulation and add value and meaning from it. So the key aspects to think about are the process, how do people engage with each other, what's the psychology, so what are the moral and political pressures that people are under. People at the top might have to answer to other people outside simulation. They might be worried about their future chances of being re-elected into post, for example. They might know that a particular community would be displaced from a certain decision. So there's all those aspects outside of a given number of options which need to be considered. And how do you create empathy? Are there ways of making people more visually and mentally engaged? So essentially, it's all about engagement. And what we wanted to do, I've missed a few clicks there. So what are the methods and technologies out there that can enable that engagement and empathy? I don't know, can you have a quick show of hands who's tried Google Cardboard or is aware of it? Has anybody else gone beyond Google Cardboard and tried virtual reality? Okay, so about 50%. That's not bad, actually. Very good. And how many people think it's a good technology? A few less. But yeah, so one of the ways of engaging is, what's the lowest common denominator? What's the cheapest method of getting that technology out there to get adoption and awareness? And Google Cardboard's a great way of doing this. For the cost of a couple of pounds for the cardboard and using people's own smartphones, this is a new and quite exciting way of pushing information out to end users. If you build an app into that application, you can actually get them to feed information back. So there are potentials there of creating much more effective engagement. Another great example I've come across, which is a little bit of VR, so it was more AR actually. This is called the Owl Eyes. This has come from a company in somewhere in California. I've forgotten where exactly, but they've integrated a tablet into a rather nice Art Deco binocular housing. But inside it, they're actually projecting in what a future development might look like. So they can put these onto the pavements at key locations around development, bolt it into the ground. It's incredibly robust, waterproof, vandal-proof, and they can show, and people can look around and see what it's going to look like. They can also collect information through questionnaires and voice messages, so they can actually bring information in. Now, my understanding is traditionally, if we do public engagement, this tends to be in a excuse me, tends to be in a public office in a town. Forgotten the word. But basically, they do them in over lunch times that people aren't necessarily available. They only get a subsection of the population, and so this is a potential way of gaining more information, putting the word out, and getting feedback. So hopefully, this type of technology can give greater insight and perspective, and involve more stakeholders in experimentation and optioneering. So the other thing with virtuality that you might have heard of is the term immersion. I first came across it with Palmer Luckey talking about the Oculus Rift. And this is the immersion into virtuality is a perception of being physically present in a non-physical world. The perception is created by surrounding the user with VR systems and images, sound and other stimuli that provide an engrossing total environment. So you've all seen The Matrix, and their way of recreating this is to tap directly into your spinal column and create simulations and sensations similar to what you'd have in a physical world, so you don't even know you're in it. Now, we're not there yet. Yes, exactly. And I don't think we need to. All the literature says, the more senses you bring into an experience, the better it will be. But what we've seen is that people are willing to make up things that aren't there. If they are a little bit like a hypnosis, if you want to believe and you want to enjoy something, you will actually fill in the gaps and you'll forgive some of the shortcomings of a simulation. And so what we're trying to do as part of that is understand what are the minimal things that we need to do to get a good experience and for what outcome. For example, this thing called Omni Virtuix is going to be released soon. This will allow gamers to get off the couch and to run around like frantically in their living room, chasing after each other and shooting at each other. It's probably going to change the physiology of gamers in the future. They're probably going to be one of the best athletes out there, spending hours and hours and hours running around with other people around the world, probably using John's platform. So they know it's not real. They know they're walking on a dome and they've got little balls on their shoes and they're walking on a dome. They don't care. They're enjoying themselves. They're actually getting to that next level of engagement with a virtual world and forgiving it its shortcomings. The other interesting thing we've done as a project here is create a virtual prototype, a virtual experience of being in a pod. And this was intended as a marketing activity initially. But it showed some interesting results in the sense that people got into the pod. By physically getting into the pod, they were in the zone, they were in the future, and we're going to try a ride in the pod. And we put on a VR headset and created some sounds that represented what it like to be inside the pod. Half of the people believed they were moving. Half the people thought there was actuators on the side and they're moving around and they're looking over their right-hand shoulder to make sure that it was clear to turn into the path of traffic, and we're checking that people were out of the way as the vehicle was driving along. So that kind of gives some additional sense that actually we don't need to create all the sensors, just a few of them at the right time for the right application. So for those of you who are not aware, VR tends to be driven by virtual reality. Virtuality tends to be driven by gaming engines, of which Unity and Unreal are the two leading software vendors. And most commonly used, Unity primarily because you can now put to multiple platforms, so as well as a high-end virtual reality experience with an Oculus Rift, you can also output the same content in a reduced format to mobile platforms. The types of headsets out there, as I already said, are cardboard, the Gear VR, which is the next level of robustness on from this. Then we've got the Oculus Rift, the HTC Vive, both of which are now doing hand tracking and are also allowing you to move around a chaperone space. So essentially you can move to a small degree, depending on the size of your room, within the virtual world, and it creates a virtual net around you that stops you bumping into your furniture or smashing your TV or hitting your family member over the head, which is one of the problems of virtual reality because it really isolates you from reality. So we've got these technologies in the lab, and we're now moving on to some of the more advanced forms of virtual reality technology and augmented reality, as well as different methods for capturing your digital environment. So there's haptic glove we just saw, so that gives you a claim, and we'll find out, to feel the sensation of the wind on your hand and the butterfly on your finger. Leap motion allows you to capture your digits and interact more intuitively and naturally with virtual reality, and that straps to the front of your VR headset. Then we go on to augmented reality tools such as the Microsoft HoloLens. So we can now formally get hold of this in the UK, and we'll be buying one to complement our suite of kit here. And this is a good example of combining two-dimensional design activity with three-dimensional design activity, being more aware of what you're designing by being able to manipulate it and interact with it. So of interest, anybody here played with the HoloLens? Who'd be interested in playing with the HoloLens? Sorry, working with the HoloLens. Okay, interesting, thank you. And the interesting part of the HoloLens is all contained in a headset, so you can take it around. You have a big computer with you. It's also recognising hand gestures as a means of interacting with the computer, which is particularly interesting with my interest in Minority Report, being able to interact in a more natural and intuitive way with computers that doesn't require a desk and multiple keyboards and known keystrokes. We're also going to be buying a haptic suit. So this is from a company based in Scotland called Tesla, funnily enough, but they make a suit. Again, this really creates pressures and sensations. Again, we don't know how useful this will be, but we're hoping that we can be that one-stop shop where we can do the acquisition, we can expose and provide advice as to how to use this technology, what's best to suit the needs of different projects. And then some of you might be aware of Magic Leap. So this is the small company that has managed to acquire billions of dollars of investment and haven't actually produced a prototype to the public yet. But this is looking at retinal projection. So their aspiration is to take something that's now the size of a computer and miniaturize it into a wearable headset and projects onto the retina, so there's no need for displays, there's less challenges for resolution to be improved. So as you can see, there's lots of different peripherals out there with potential applications. We have been doing a number of activities with the kit we've got, and our objective, as I said, is to become that one-stop shop for the transport industry to think about what can we do with this technology, how can we apply it, what's the best one for us, will it work, and we can be honest about the applicability of these technologies, saving you time and money, so you don't have to go out and learn and bring in expertise. Hopefully we can be that consultant and that advice for you. So the task we've been sitting through is, can we build a virtual environment that was familiar, one which the TSC was actually involved with, so Milton Keynes. And task 2, identify what peripherals to add value in VR interactivity. Number 3, identify pertinent sensors to simulate, to generate that level of immersion, that necessary level of immersion. How to improve immersion and learn about the technologies and some of the subtleties of their use. And to integrate transport models and simulations. So that's where it links into today's discussion. So we've been doing some work with our colleagues in the modelling part of modelling and visualisation to see how we can actually use simulations of vehicles and pedestrians to augment those virtual environments. And task 6, which is part of today, is promote and engage, re-evaluate, enhance, and to create collaborations. So I'm going to quickly run through some of the projects because I realise we're already 60 minutes in. One of the challenges we want to do is, can we use VR to run user trials with autonomous vehicles? So the Lutz Pathfinder project has been very much heavily focusing. About 2 minutes. 2 minutes. Okay. It's been focusing on technology, but what about the human? How do we get human feedback into that process? And how are we going to respond to autonomous vehicles, either on pavements or as you cross the road? There's a whole load of communication that's going to be missing by taking people out of the vehicle or having people in there which are not concerned about driving. So all the eye contact, any hand gestures, use of the horn, that's going to go away. So what are we going to do to understand what that vehicle's going to do next? And how do we feel and perceive that vehicle's characteristics in our nexus, in our feelings of being safe and what to do next? We've all done that shuffle on a pavement or in a corridor where you'll go the same way. So what is that relationship with vehicles? And the idea is that we can use virtual reality to simulate those conditions and to understand what the options are that will make sense to move forward with. So the other challenge is, how can we populate 3D worlds with agents? And this is where we've worked with our modelling colleagues. Part of the CAV and the HATS project was to bring 2 simulations together, so a pedestrian simulator and a pod simulator. Pedestrians got into pods and moved around this virtual world, and this is the early Milton Keynes before we made it more attractive, and had a number of challenges getting everything to align properly on the right coordinates, but ultimately has demonstrated that if we could effectively integrate simulations with the virtual reality environments, they'd be a lot faster to build. Animating every agent in environments is very costly and time consuming. So there's a real opportunity there to make these environments active and dynamic by use of simulation, and we want to investigate that in the future. Ultimately, what we want to do is create a matrix kind of environment with an architect coordinating all the pawns in that environment and understanding what the effect of certain instances and what the outcomes will be. Very briefly, if anybody's interested in discussing after, because Hugh's telling me to hurry up, we're doing a project at the moment, it's a live project, where we will be installing sensors into Milton Keynes train station. This will be tracking pedestrian movement and will link to MK Smart, where we already have sensors in the plaza area tracking people's movement. And we've integrated this with the live data so we can see people's live movements. And the idea is that as a result of this project, we'll have a huge data set of people movements which can input to pedestrian simulation from a point of view of looking at how well the simulations are representing actual movements and improve the next generation of pedestrian simulators. Jump forward. I've got a few too many slides, haven't I? Sorry. So where to next? So we want to continue further integrating and learning about these 3R peripherals and virtual environments. Very keen to investigate multi-user interaction in virtual worlds for the means of if we can prevent people travelling to design meetings, for example, allow them to engage more effectively in virtual reality, they might be able to have a more rich experience of and a richer collaboration by collaborating in virtual reality over a CAD model, for example, and save potentially millions, not billions, of miles for business purposes. That is really, really close to being possible, and we're hoping to showcase in March, along with the digital Catapult, the first steps towards doing that. We want to continue identifying the best HMI for interactions with simulations. The more natural it will be, the more engaging and adoptable it will be. We're very keen to talk to anybody looking at agent-based simulation, so we can have that two-way interaction between simulation and person experiencing virtual reality. And for those of you interested, we've got a workshop in February, which is looking at how can we build virtual worlds faster. So one of the biggest challenges is the time it takes to build virtual environments. If we can make those faster and more people can afford to have them, they've got an asset they can do more with and create greater opportunities. If anyone's interested, there's the email on visualization@tscatapult.org.uk. That's me done. Thank you very much.